Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone. We are going to solve a very special problem. It is an integral problem by the great mathematician Cornel from Romania in his book Almost Impossible Integrals, Sum and Series. This is our problem today. The integral from 0 to 1 tan minus 1 x over x ln 1 plus x squared divided by 1 minus x all square dx proves that this integral equals pi power 3 over 16. This is Mr. Sherif Hamid with you, math and mechanics teacher at STEM Kafr Sheikh High School in Egypt. Let's start with the properties of ln to divide this integral into two main integrals. So that the first one will be integral from 0 to 1 tan minus 1 x over x ln 1 plus x squared dx minus integral from 0 to 1 tan minus 1 x over x ln 1 minus x dx. I will start with the second part. Of course, we can use series properties to solve this problem. And tan minus 1x, it is the same as sum k equals 0 to infinity negative 1 power k divided by 1 plus 2k times k to the power 2k plus 1. Of course, as we know that we are dividing by x, so it will equal x power 2k, and we can use double integral to solve such a problem. As we know that ln 1 minus x, it is the same as integral from 0 to x 1 over 1 minus y dy. And we can change the order of integration by determining the shaded area, which lies between x equals 0 and x equal 1, and y equals 0 and y equal x, and change the horizontal and vertical slice. So we will obtain the integral will be negative sum k equals 0 to infinity negative 1 power k divided by 1 plus 2k. Double integral, the one from y will be from 0 to 1, and the one from x, which we will get started from y to 1, x power 2k. Of course, x power 2k, its integration with respect to x will be x power 2k plus 1 divided by 1 plus 2k. So the 1 plus 2k will be squared, and the integral will be negative sum k equals 0 to infinity negative 1 power k divided by 1 plus 2k all square integral from 0 to 1 1 minus y power 2k plus 1 over 1 minus y dy. After, of course, we substitute the values of x with y and 1. And this is very important and very famous integration that called the harmonic number. The harmonic number n equals integral from 0 to 1 1 minus x power n divided by 1 minus x dx, and substitute n with 2k plus 1, so the integral will be negative sum k equals 0 to infinity negative 1 power k times the harmonic number 2k plus 1 divided by 1 plus 2k all square. Also, from the properties of the harmonic numbers that we have, the harmonic number n plus 1 equals the harmonic number n plus 1 divided by n plus 1, and we will just substitute in our formula. So harmonic number 2k plus 1 equal harmonic number 2k plus 1 divided by 1 plus 2k. Back to the same series that we have here, and we'll just substitute. So our integral will be converted into this form, which will be negative sum k equals 0 to infinity negative 1 power k harmonic number 2k divided by 1 plus 2k all square minus sum k equals 0 to infinity negative 1 over k divided by 1 plus 2k all power 3. And this is very famous series, as we will show later. So our main issue is to get rid of this sum, the first sum. And we will go to the first integral, but we will use a very famous formula that calls a tan minus 1x over x ln 1 plus x squared. It is the same as negative 2 sum k equals 0 to infinity, negative 1 power k, harmonic number 2k divided by 1 plus 2k times x to the power 2n. Of course, it was x to the power n plus 1, but we divided by x, so it will be x power 2n. Okay, we will integrate both sides for x from 0 to 1. So we will obtain that our main first integral will be negative 2 times sum k equals 0 to infinity, negative 1 power k divided 1 plus 2k all square, harmonic number 2k. If we substituted this at the main integral, which is as we can see here, we will find that we will have two values will cancel each other, which will be negative 2 times some k equals 0 to infinity, negative 1 power k over 1 plus 2k all square, harmonic number 2k. We'll cancel this one after it multiplied by negative 2, so they will cancel each other, and this one will remain positive times 2. Okay, everyone, and the problem is almost finished. This calls the Dirichlet beta function, which is defined by beta s equals sum n equals 0 to infinity, negative 1 power n divided by 2n plus 1 all power s, and it is the same as our problem, just substitute s with 3, so the value will equal pi power 3 divided by 32. But we are multiplying by 2, so our answer will be 2b3, which will equal pi power 3 over 16. I hope that you found this solution helpful for you, and I will see you with another advanced problems in calculus. See you soon. Goodbye.